Alrighty, so here to talk about SDN and where are we going, and all that good stuff. This is the shotgun version. So as we all know, technology is really centering around the application because this is really where, at the end of the day, consumers perceive value. Okay. And then as a result, this is where companies perceive value. So a lot of the money's been moving to line of business, to how do we account for things like mobility, cloud, everything's been changing. We've talked about this. Advanced threats have been increasing. Pretty much at this point, what used to be an advanced persistent threat a couple years ago, now a script kid you can buy for 50 bucks online. So we've got a problem. How do you get availability, quality of service, and time to market? These are kind of the problems that we're all really dealing with, and this is what SDN has entered. So we're facing with a whole bunch of business challenges and a new concept called SDN, and the question is, how do they all fit together? So let's look at some of the challenges and how we scale the modern data center. Basically at the top, we have an architect, which is really a representative for the line of business saying, hey, I've got an application, network engineers, I need you to go do this. And at which point, since almost this entire panel is technical in some way or the other, we all start cursing under our breath and go, seriously, why? Why? Don't make me change it, it's gonna break. I've got 10,000 applications to manage. Don't make me touch the network. And really, because the problem is, the only place where you actually have the configuration, you can actually understand the combination of the static and dynamic policy of the network is in the data plane itself. You gotta go down to those boxes, figure out what the config is, kick off a whole process to figure out whether that change is safe, and then you gotta figure out how to implement it. And that's where you get that manual and scripted configuration. And it doesn't really matter if you're in an enterprise data center, service provider data center, private cloud, public cloud, hybrid cloud. It all boils down to the same thing. The data plane is where all your information is, and hopefully you don't break it. But if you do, you hope that you break it today and immediately, not 6 hours later as your convergence protocols start realizing that you actually have a cycle and start kicking back and you've got a big nasty problem. So basically the upshot is it's really time consuming, error prone, and really difficult to debug if you get something wrong. So SDN, everyone's claiming SDN is the answer, right? That kind of begs the question of what is SDN? So if you go back, starting about 2008, 2009, the first version of the definition was actually pretty simple, although it was used mostly for how do we generate routing protocols, not for how do we manage a whole data center. And it really was, let's separate the control and data plane, so then we can have general for-read hardware, but we really centralize this logic and we get a lot of benefit. At which point, OpenFlow kind of took off. Virtual networking said, there's some other things we could do, and OpenFlow's not so great at it. It started taking off. Service chaining is like, well, really, I just want to solve how do I tie my services together. Can anyone recognize what the next piece of this graph is going to be? It's a Gartner hype cycle. So the question is, we have a lot of technologies that have all kind of peaked and come back down, but the problem is they're all technologies. They're toolkits. And someone made this comment earlier during the keynote. It's really a grab bag of technologies, how we put together. And now we need to start moving on to the slope of enlightenment so we can actually start solving customer problems. And really, if you look at it, I think it's really going to be informed from what the developers have been doing. Because at the end of the day, really, they're the root of our problems. They've moved to a world. It's true. So they've moved to a world in which 10, 15 years ago, the waterfall model broke down because customers said, I need new functionality faster and faster and faster, and it has to be higher and higher quality. So they generated test-driven development, which then led into agile development processes, so you could quickly converge onto what customers want, and you can start pumping out code on a very quick basis. And this is great for Microsoft Office, your operating systems, anything that runs on a single machine. What it doesn't really deal with is how do you deploy it in a large-scale data center? Because at the time, data centers were beginning, but that wasn't really the gist. So that's why about 5, 6 years ago, we started seeing the rise of DevOps. This is really can be thought of as taking it to the next level. We now have a set of processes, not technologies, that drove the need for how do we develop applications for the data center on an ongoing basis. And we took just enough of the operations team into the development team so they could actually manage and deploy their code in a fluid basis. It doesn't deal with networking, it doesn't deal with the storage, it's just the compute aspect, which is the domain of the applications. But what did they do? They started developing all the tool chains they needed to be able to work in this model. So we moved from the original source control systems to source control systems like Git that don't suck, SCS, RCS, Baggit. We need something that actually works. Continuous integration, continuous testing, continuous deployment, and now we're at a place where you can actually deploy code on an hourly basis and more frequently. Because all that happens is developer commits, it goes off to a staging environment, it builds it, it compiles it, it runs all the tests on. If it's good, it deploys it and then starts doing it in a phased rollout. So if anything does go wrong, it can go back instantly. These tools are amazing. But notice, they've moved to a point where they can move really, really fast. Networking and the rest of the infrastructure hasn't caught up. So the way I like looking at it, SDN is really the networking component, the parallel of what DevOps has done. We need to solve the operational challenges so we can deliver value for the end customer at the end of the day. So we start with a higher level question of what do we want to accomplish, and then we go choose the tools that we need to make that all happen. Because really at the end of the day, SDN, SDI, SDE, SDDC, it's all about how do we operationalize the data center at the end of the day. And that was the point about programming. At some point, policy has to turn to something that actually makes sense. So with that, I went back to the original definition and kind of jury-rigged it a little bit. And this is the definition that I put together for F5, where really, again, it's about the value proposition. How do we improve our time to market? How do we reduce our risk? How do we reduce our operating expenses? Although with this audience, I'll just say that's kind of questionable because complexity is complexity. It always exists. So you got to pay the price somewhere. Maybe we can reduce it a little bit, but we're going to deal with it. But you do that by centralizing everything for your local risk domain into one control system that understands how to scale, how to deploy, how to manage your networks. I was talking to a financial where they'd actually built a compiler for firewall rules that would take your application set of firewall rules with a small feature set and then deploy it across several hundred firewalls globally so that anytime you change an applications policy, it recompiled and pushed it back out. You never had stale rules anymore. That's really impressive. Now, to the point of programming again, 25% of their NetOps team are software engineers. So the only way to do that is have people who understand the network, working with people who understand deep programming so they can do graph theory and come up with all the graphs that it takes to build a system like that. So, but now here comes the real cool thing. It's great about pushing packets, but we can't forget about all the stateful layer 4, layer 7 components that are in the network. These are kind of important because these are the bread and butter of how we stitch our applications together. How do we put our policies and stitch components together? If you look at it, probably about 80% of the complexity of actually deploying an application are sitting in the stateful services. And these include your layer 4 firewalls at the simplest layer. Once you get into policy management, layer 7 traffic management, life becomes really, really difficult, really, really fast. How much time do I have? Okay. So what's going to change? So when you operationalize the network with SDN, again, the architect says, hey, go do this. The networking engineers and admins, now their roles kind of changed. Really, they're kind of going to move off to the side a little bit. They don't go away, but they need to understand how to teach a control plane or an orchestration plane how to configure and manage the dynamic and static policy of the network. So you look at even with, say, an NSX, you're going to have to do something that can deploy a complex application. That's not straightforward. For the really simple stuff, yes, you can point and click, but how do you build an automation system that lets you create a more complex app that you wrote? With Cisco APIC, again, how do you write a more complex system that deploys a complex SOA-type application across your data center? So they're the only ones who understand the intricacies of the applications and that particular network. So their job has to be refocused a little bit. And then they turn around and change that manual process into a fully automatic process because now you have centralized everything and it can push out the changes. No more fat finger typos on one little switch breaking your spanning tree protocol. So what would I like to see? Let's go into the realm of futures. What I really see is once you've got this centralized config, now you have centralized knowledge for the first time of your network and all your entire data center and infrastructure as you keep scaling up. Which now means we need to start developing new tools. How do you develop tools that let us introspect on the state of the config so we know whether changes are going to be happy a priori or not? Then once we've done that, we can actually start checkpointing configs and roll back just like the DevOps teams and get back to a stable point. So you don't get 5 nines of reliability on whether you're going to make your change or not. You don't need it. Because the worst case that's going to happen, your network may go down for a minute or so, and then you automatically revert, and back you go. So I think there's a lot of space in the technologies that are beyond what we've been looking at that make life good. So at the end of the day, there was the mainframe comment. I'll see you back and say, it's really all about going back to 1961 with utility computing. And that's exactly 10 minutes. Press up.